Okay, video number 3 for section 4.4. There will actually be 5 videos. I forgot there were actually 3 more examples here. These will be much shorter. So 1990 AB number 1. By the way, every number 1 and number 2 that you come across will always be calculator active if you're going to practice any of these. Number 3 has changed over the years, so it depends on what year it is. But 4, 5, and 6 are always going to be non-calculator. Just to let you know if you're going to practice any of these. Okay, the 1990 AB number 1. A particle initially at rest moves along the x-axis so that its acceleration at any time t is greater than or equal to 0 is given by a of t equals 12t squared minus 4. The position of the particle when t equals 1 is x of 1 equals 3. Find the values of t for which the particle is at rest. All right, if we want to find the values of t for which the particle is at rest, what we're going to need to know is what the formula for the velocity is, and then set that equal to 0. All right, so it gives us a bunch of information up in the top that we're going to have to use. First thing is, I know that velocity is the antiderivative of acceleration. So let's see, the antiderivative of acceleration is going to be 4t cubed minus 4t plus c. But they gave us enough information to find c because it says initially at rest. So initially at rest, initially means time 0, at rest means the velocity is 0. So really what that's giving us is v of 0 equals 0. So that means 0 is going to equal c if I plug in 0 for all my t's. So the velocity function is just going to be 4t cubed minus 4t. And the problem is actually asking all the values of t for which the particle is at rest. So we want to know when that equals 0. Do a little bit of factoring. Pull a 4t out. That'll leave us with t squared minus 1. So either t is going to be 0 or t is going to be plus or minus 1. Now, our domain here, let's see. Yeah, the domain is for t is greater than or equal to 0. So the minus 1 for t doesn't make any sense. So the times where the particle is going to be at rest are t equals 0 and t equals 1. Those are the times where the particle is at rest. All right, write an expression for the position x of t of the particle at any time t is greater than or equal to 0. So we know that the position function is the antiderivative of velocity. So, and they call this x of t. So let's see, the antiderivative of the velocity function is going to be t to the 4th divided by 4, so that's t to the 4th. Minus the 4t, so it's going to be t squared, so it's going to be minus 2t squared, and then plus, again, some other constant. We can call it c, you can call it d, whatever you want to. It's a different part of the problem. But we were given some kind of an initial condition for that. Right there, x of 1 equals 3. So that basically means that when the t value is 1, the x of t is 3. So 3 is x of t. Plugging in 1, again, 1 raised to any power is 1, so 1 to the 4th is 1, minus 2 times 1 is 2, plus d. So let's see, 1 minus 2 on the right side is negative 1. So if I add that to the left, we're going to get that d is 4. So x of t is going to be t to the 4th minus 2t squared plus 4. That's the position function at any time t is greater than or equal to 0. And then we have to find the total distance traveled by the particle from time t equals 0 to t equals 2. Total distance is the integral, so integral from 0 to 2, of the absolute value of the velocity. And let's see here, the velocity function was 4t cubed minus 4t. So this is something that you can plug into a calculator. Since it's on a calculator portion, we're going to go ahead and do that. So let's see, Math 9 0 to 2. Need to do the absolute value, so that's math, num, and then absolute value is the first one. And I think that I've already forgotten what the velocity function was. I'm going to scroll back up there and see. 4t cubed minus 4t. 4t cubed minus 4t dt. Remember, I'm just using x's in place of this. It doesn't really matter what the variable is. And 10. Wow. Came out to be a nice whole number. And were we given units on any of this? It does not look like it, so I don't have to include units on any of these things. So total distance this thing traveled was 10 units. All right. Like I said, these will be much shorter videos. So I just did that entire problem in under 6 minutes with explanations for everybody. So if this was a 15-minute problem, you would have had plenty of time to do it, even if you had to think about these things just a little bit more. All right, we will come back with another video for the next problem.